Alright, in the last video we wrote out Lewis dot structures for a few different molecules. In the next few videos I want to do some more easier Lewis dot structures and then get increasingly more hard or complicated maybe, and hopefully not even, it won't even seem like we're even getting more complicated because it'll just kind of have a natural flow using these guidelines and these rules to help us get there. So we did these last time. This time I want to go ahead and let's start with a different carbon molecule here, and let's do let's maybe do C2H6. Okay. Now we know that carbon generally likes to be the central molecule, so we're going to write this out as carbon. There's two of them, and they're going to be held together by at least a single bond. So I've got single bond there, and then we've got six hydrogens. So, I want to write an H there, not a 6. Got a hydrogen here, got a hydrogen here, hydrogen here, hydrogen here, hydrogen here, and a hydrogen here. And we know that all these hydrogens are all held together by at least a single bond also. And you may notice a pattern going here with this. But we attach all those electrons in our Lewis dot structure, and then we add up our all our valence electrons. We know that carbon, if you remember from the periodic table, likes to have 4 valence electrons, and there's 2 of them, so there's 8 there. And hydrogen likes to have 1 valence electron, and there's 6 of them. So we've got 6 there, so that's 14 total. 14 total. If we don't use 14 electrons whenever we draw this out, we're wrong. So let's double check, make sure we did 2, 4, 6, 8, 10, 12, 14. So we've used all of our electrons. This is the Lewis dot structure for C2H6. That would be ethane, is what we just drew out there, ethane. So let's do one that's maybe a little bit more complicated here. This is kind of easy, especially when you have carbon, because you just fill in the hydrogens there and they're all coming together. But let's do one that's a little bit more complicated. Let's do C2H4. C2H4. And let me put a little speck right there. Alright, so we know carbon, and let me change colors there. Carbon, actually that's a little too dark. Let me go to a brighter color. Carbon likes to be the central atom, and there's 2 of them. Going to be held together by at least a single bond, and we have 4 hydrogens this time. So let's go to different color for hydrogens. So we've got hydrogen here, hydrogen there, hydrogen here, and maybe hydrogen there. Let me space these hydrogens out just a little bit further from the top. There. There. Alright, and those are held together by at least a single bond. So we got another hydrogen, 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 hydrogen. Alright, now all we need to do is add up our valence electrons over here. Let me just draw a quick line in between these so we know what we're working with. We know that carbon likes to have 4 valence electrons, and there's 2 of them, so that's going to be 8 electrons for carbon. And hydrogen likes to have 1, and there's 4 of them, so that's going to be 4 for carbon, or for hydrogen. That's going to be 12 electrons total. We know that if we don't use 12 electrons in our Lewis dot structure, that we've done something wrong. So we've got 2, 4, 6, 8, 10. 10 electrons in our Lewis dot structure here. So I just need to add 2 more. Let me just add 2 more just right here. There's absolutely no specific reason why I added them to this carbon versus that carbon. I'm just simply throwing them in there so that I have all my electrons used in my Lewis dot structure. Okay, so I don't mean to confuse anyone by doing that. That's why I put them in there, just because I simply have to have 2 more so that I have 12 total. So let's take a look at this here now and see if this worked out. We've got 2, 4, 6, 8 electrons right here on this carbon, and we've got 2, 4, 6 on this carbon. All of our hydrogens have 2, which is what they want, so they're happy. But this carbon only has 6 valence electrons now, and this one has 8. So something's not working out there right. We didn't draw it right correctly, or we must not have drawn it correctly. So next thing that we go, if you remember from the first set of videos on Lewis dot structures, when I was talking about double and triple bonds, a single bond looks like this. If that doesn't work out, then you go to a double bond, which would look like that. So that didn't work out. Let's try a double bond now. So let me grab a different color here. We got carbon, carbon, held together by double bond this time. And basically what I'm going to do, it wouldn't make sense for me to take, I've got to bring 2 electrons from the outside of carbon here in order to make this a double bond right in there, right? In order to make this a double bond right there. It wouldn't make sense for me to take, these 2 or those 2 from this side, because this side only has 6 valence electrons. I need it to be 8. And you don't add 2 more, you don't get to 8 by subtracting, you get to 8 by adding. So I'm basically going to take these 2 electrons, or these 2, or these 2, it doesn't really matter, and bring them over to make it a double bond. So effectively, we're going to be taking these 2 and putting them right there. And that's what I'm drawing out here. And so now we've got our hydrogen, and let me even go a little bit further down here. I'm not really crunched for space. I don't know why I'm crunching all this together. Got a carbon, a carbon, 4 hydrogens, and we've got double bond here now. And then single bond there, single bond there, single bond. Okay. Need to make sure we're using all 12 electrons, 2, 4, 6, 8, 10, 12. Single bonds on our hydrogen, because they only want 2, so they look happy, look happy, look happy, look happy. Let's check out our hydrogens now, or our carbons now. We've got this carbon sharing all those, 2, 4, 6, 8. We've got this carbon sharing those, 2, 4, 6, 8. It looks happy. Now, that's a double bond that's characterized in there, and that's a little bit more difficult. Let's try a different one that's not using carbon, because we've been kind of using carbon all along here, and it's getting a little predictable. You can kind of see where a double bond would come in. If you look between H6 and H4, you can maybe kind of predict that a little bit. If I said this was C2H2, you'd probably say, well, that's got to be a triple bond at that point. But let's go ahead and work with a different molecule other than carbon and hydrogen here. Let me go and scroll down just a little bit. And actually, you know what, I'm about out of time. I'll go ahead and save that for the next video. So in the next video, we'll work with an even more complex compound here, perhaps, and write the Lewis dot structure for that.